Hello students, I'm here again, your online teacher in General Mathematics. We are now on the third chapter of our General Mathematics because in chapter 1, we discuss about functions and relations represented by different ways. Second chapter was talking about the basic functions together with their graphs. And this time, we are going to start discussing the third chapter of our lesson, which is evaluating a function. This lesson is not new to you because you have already taken up the idea of substituting the value of x in order to look for the value of y. This is particularly taken during your grade 10 mathematics. And this is the continuation of that particular lesson in junior high school mathematics. We are going to substitute the value of x in order to look for the value of y. And these are the objectives of our lesson for today. At the end of this video presentation, you are expected to, number 1, demonstrate your understanding about evaluating a function. Number 2, evaluate different types of function. And what are these different types of functions? Of course, we have the constant function, we have the quadratic function, we have the cubic function, we have the quartic function. Quartic function is a function with degree 4. And we have the quintic function, and it is a function with degree 5. We have also the absolute value function. We have also the identity function, and another function that we are going to discuss will be the greatest integer function, and we have also the piecewise function. Now, what do you mean by evaluating a function? Evaluating a function means replacing the variable in the function with a given value. In this lesson, the variable x is given a value from the function's domain and computing for the result. And that is looking for the value of y, or we have the so-called f of x. Because in this particular lesson, we will no longer use the variable y. Instead, we are going to replace y with function notation. Then, you are going to consider this function machine. This is a function machine in which we have here the input. Our input is the variable x, and we have here the function rule. So when we say function rule, it is talking about the indicated operations of the particular function. And it is also talking about the different types of functions that we are going to evaluate. And take note, we are always having the so-called the 4 fundamental operations of mathematics together with the symbols of grouping. And we have also the exponential expression. Then after the manipulation of the particular operation in our function, because we are going to substitute the value of x with a given value, either constant or a variable or a polynomial, we have a certain output. And this output is y is equal to f of x. And f of x is the common notation for our y. We can also use another variable to denote function. We can have the g of x, we can have also the h of x, and these are the 3 function notations that we are going to use. We have the f of x, we have the g of x, and we have also the h of x. Take note, if our manipulation of the operations or the symbols of groupings, or we have the exponential expression is wrong, our output is also wrong. Therefore, our output is dependent from the input. If our input is very good, but the manipulation of that input is wrong, we can have a very wrong output. That is why in the function rule, we are to be guided with the basic operations in mathematics. another function machine. So we are going to have the input here, and the function machine is manipulating the operations inside the machine. And we have, of course, our output. Output is depending upon to the input. For instance, if our input, for example, is meat, our output would be corned beef, etc. That output is based from the input. Okay, now, this time, we are going to apply that particular idea in mathematical expressions or mathematical equations. Now, letter A, evaluate the following functions at x is equal to 1.5. I hope while watching this video presentation, you have your scientific calculator because we are going to use the decimal number here, no? Okay, number 1, f of x is equal to 3x minus 2. Number 2, f of x is equal to 3x squared minus 4x. Number 1 function is a linear function. Number 2 is quadratic function. Number 3 is square root function. F of x is equal to square root of x plus 4. And number 4 is a rational function. F of x is equal to 2x plus 1 all over x minus 1. Number 5, f of x is equal to greatest integer function of x plus x. This is a greatest integer function. And we have number 6 is also a greatest integer function. F of x is equal to negative 2 greatest integer function of x minus x. And number 7 is f of x is equal to 2x squared minus 5x plus 3 is a quadratic function because this is degree 2. And the graph of this particular function is parabola opening upward. Okay, number 8. F of x is equal to 3x squared minus 8 all over 5 minus x. And this is a rational function. Number 9. F of x is equal to 2x squared minus 5x plus 3. And this is a quadratic function. And number 10 is f of x is equal to, okay, we have the cube root of 2x minus 11. And this is a radical function. This is also a radical function, but specifically, this is a square root function. This is a radical function, specifically cube root function. Now, we are going to solve number 1. What is the value of y if our x is 1.5? Now, we are going to substitute the value of x with 1.5. Therefore, we have f of 1.5. Take note, we do not have any more a variable x here. Instead, that x will be substituted with the value which is 1.5. 1.5 is a constant. Therefore, 3 times 1.5 minus 2. You are going to multiply 1.5 with 3, and what is the result? That is 4.5 minus 2. Okay, 4.5 minus 2 because 4.5 is the product of 3 and 1.5. Then you are going to subtract and the result is 2.5. This is our output if our input is 1.5. Now, if your answer, for example, is 3.5, your manipulation, your function machine is malfunctioning. That is why it got a wrong answer. That is why you are going to review the basic concepts in the operations of arithmetic so that you can have the correct output depending upon to the input. Now, how are we going to evaluate function number 2? And this is quadratic function. What is the value of y if our x is 1.5? We are going to substitute. X here will be 1.5. Therefore, f of 1.5 is equal to 3 times 1.5 quantity squared. We have the exponent here. Our x is no longer seen here because all the x's here are given a value of 1.5 already. 3 times 1.5 quantity squared minus 4 times 1.5, you are going to simplify its term. What you're going to do is to simplify first the exponential number, or you are going to remove first the symbol of grouping. But prior to that, you are going to remove first the exponent 2. It means that 1.5 will be multiplied by 1.5 itself. Okay, therefore, 1.5 times 1.5, what is the result? 1.5 times 1.5 is 2.25, and that will be multiplied to 3. Okay, this is it. Then, you are going to multiply 4 and 1.5, and the result is 6. 1.5 times 4 is equal to 6. Okay. Then, after that, we do not have anymore the exponent. We are going to remove now the symbol of grouping, which is a pair of parentheses here. How are we going to remove this? We are going to multiply 2.25 by 3. Okay, what is the result? 2.25 times 3 is equal to 6.75 minus 6. This is it. 6.75 minus 6 is equal to 0.75. Now, if x is equal to 1.5, our y is 0.75. Take note, starting today, we do not anymore use the variable y. Instead, we are using the function notations. And what are the 3 commonly employed function notations? We have the f of x, we have the g of x, and we have the h of x. And we have also other variables which are being used. Now, we will proceed with problem number 3 or function number 3. This function is a radical function, specifically a square root function. Now, take note, if our answer is irrational number, you are going to round up your answers in nearest hundreds. It means rational number is a number that cannot be expressed as a fraction of a and b, wherein a and b are integers. It means these are the numbers which are non-terminating and non-repeating. And these are irrational numbers. Irrational numbers are more than the rational numbers. It means that the set of irrational numbers is uncountable, while the set of rational numbers are countable. Because when we say countable, it is a set in which it can be mapped with one-to-one correspondence with natural number. We have the countable set. It could be finite, and we have the infinite. Although it is infinite, but it can be mapped with natural numbers or counting numbers. When we say counting numbers, starting from 1, going to positive infinity. And these are the positive integers. And these are the counting numbers. Now, if our answer is irrational number, don't forget to round up your answer into nearest hundreds. Okay, we are going to substitute now x with 1.5. F of x or f of 1.5 is equal to square root of your x is 1.5. 1.5 plus 4, and that is 5.5. Then you are going to calculate the square root of 5.5. You are going to calculate this one because 5.5 is not a perfect square. Therefore, it will give you an irrational number. If it is an irrational number, we cannot use, we can have the manual computation, but it requires a long time. But since we have our calculator, we are going to use our calculator to evaluate the value of square root of 5.5. Square root of 5.5 is equal to 2.35 because this answer is already rounded up to nearest hundreds. Okay, we will proceed with number 4. And this is rational function. Take note, if our answer will give an irrational number, you're going to round off your answer in nearest hundreds. Okay, f of 1.5 is equal to 2 times 1.5. X will be substituted with 1.5 plus 1 here. All over 1.5 minus 1 because you have your x here and that is 1.5 already. Then afterwards, you are going to simplify its term. So 2 times 1.5 is 3 plus 1 is 4. Okay, 3 plus 1 is 4. And 1.5 minus 1 is 0.5. Therefore, you have 4 over 0.5. You are going to divide 4 by 0.5. And this is equal to 8. Okay. Yes, 8. Because dividing number with 1/2 means multiplying that number with 2. Okay, take note of that. Okay, we will proceed with number 5. Okay, now number 5 is talking about greatest integer function and we are going to discuss this first. What do you mean by greatest integer function? Greatest integer function is given by the equation y is equal to, this is the symbol for greatest integer function. We have here the symbol, no? Okay. Y is equal to the greatest integer function of x where this mathematical term is the greatest integer less than or equal to x. It means that the answer will not be greater than the integer. It could be equal to that integer or we are going to take the integer which is less than that. It means that if our value of x is a decimal number, we are going to consider the integer which is less than that decimal number, not the integer which is greater than that integer. And it is also known as the floor function. Why floor function? Because it is something to do with, it looks like floor, but it is something like a ladder in which you are going to step from first step going to the second step, going to the third step, going to the highest step of our floor. That is why it is also known as floor function. Now, we are having this particular examples. Now, this is a number line. Okay, the partition of a number line, if we are talking about this number line is 0. To the right of 0 are all positive numbers. And positive numbers are greater than 0. To the left of 0 are negative numbers and these numbers are less than 0. Okay, the farther the distance between 0 and that of the negative number, the smaller the value, the number. The farther the distance of a positive number to 0, the larger the value. Now, how are we going to evaluate the greatest integer function? For instance, number 1, what is the value of the greatest integer of negative 5.3? Where is negative 5.3? Negative 5.3 is somewhere here. You are going to get the integer which is less than that decimal number. Do not get 5 because negative 5 is greater than negative 5.3. You are going to look for the integer which is less than that particular decimal number. That is why our answer is negative 6. Did you understand? If we have negative 5.05, our answer is also negative 6 because we are going to get the integer which is less than that particular integer. Okay, number 2. Negative 4.5. Where is that negative 4.5? Negative 4.5 is somewhere here. What is the integer which is less than that number? And that is negative 5. Do not get negative 4 because negative 4 is greater than negative 4.5. Did you understand? Okay, number 3. Negative 4. The answer is negative 4 also because the definition of greatest integer function is is the greatest integer less than or equal to. If our number inside the greatest integer symbol is uh, is an integer, the result is also an integer. Okay. Take note, all the values of y here are all integers. No? All integers. There is no value of y that will be coming out as decimal or fraction. Number 4. How about if our integer is negative 3.06 and that is negative 4 because this is the integer which is less than negative 3.06. Number 5. Negative 1.8 and this is negative 2. Number 6. 1.6. Okay. And where is 1.6? 1.6 is somewhere here. Therefore, take the integer to the left of that decimal number and that is 1. Did you understand? If the number is decimal, take the integer to the left of that decimal number to have the answer. Number 7. 1. And this is 1 also. Okay, because of this definition. Greatest integer less than or equal to x. Okay, number 8. 2.8 and that is 2 because 2.8 is somewhere here. And what is the integer to the left of 2.8? And that is 2. And 9. 3.01 and that is 3 because 3.01 is somewhere here. And to the left of that decimal number, the integer to the left of that number is 3, positive 3. And last number is 4.8. And where is that 4.8? Somewhere here. Therefore, to the left of 4.8 is 4. Now, what is now the graph of this particular basic greatest integer function? We are going to use these values of x as well as the values of y to sketch the graph. And this is the graph. Why step function? Because from this first step going to there, it is something to do with a ladder going upward there. Now, if x is negative 5.3, where is that negative 5.3? Negative 5.3 and our y is 6. This is it. Did you understand? Then if our x is negative 5 and we have also negative 5, that is why you have here the we have here the closed circle. It means that in this particular horizontal line with a subdomain, so this point is included. And we have here the open circles here. Okay, because it should not be having a closed circle here because this is no longer a function if that is the case. Because if you're going to have the vertical line test, it intersects the graph into 2 points and that is no longer a function. So this is the graph of greatest integer function of x. Now, if x is equal to 2.8, where is the 2.8? 2.8 is somewhere here and our y is 2. And this is the graph of the greatest integer function. Y is equal to the greatest integer function of x. Okay, now, this is just only a review because this is not the problem that was being indicated in the example that we had. Now, if x is 1.5, okay, this is our evaluation of the function. And this is 1.5. What is 1.5? What is the greatest integer function which is to the left of 1.5? And that is 1. Okay? And 1 plus 1.5. Take note, this is not a greatest integer function. Therefore, do not give the answer which is 1 because it is not enclosed with the symbol of greatest integer function. Our answer is 2.5. Okay, we will proceed with number 6, and this is also greatest integer function. If x is equal to 1.5, take note, in this particular equation, we do not have yet the value of x. Therefore, we have still here the variable x. But in the second line of our equation, x will be given a value which is 1.5. Therefore, you will no longer see a variable x in the second line because all x's will be substituted with 1.5. Okay, so f of 1.5 is equal to negative 2 times the greatest integer function of 1.5. And this is 1. Then 1 times negative 2 is negative 2 minus 1.5 is, okay. Okay, this is very systematic, no? And this is negative 3.5. Okay. Because 1.5 is 1. Because where is that 1.5? Here. And the integer, which is to the left of this decimal number is 1. Then 1 times negative 2 is negative 2. Negative 2 minus 1.5. If two integers have the same sign, you are going to add and copy the sign, the common sign. Now, we will proceed with number 7. F of x is equal to 2x squared minus 5x plus 3. And this is quadratic function. What is the value of y if x is 1.5? This is it. F of 1.5 is equal to 2 quantity 1.5 squared minus 5 times 1.5. Your x is 1.5 plus 3. Therefore, you are going to remove first the exponent. But not just only removing the exponent, you are going to simplify it. Okay. So, meaning 1.5 raised to 2, you are going to multiply 1.5 by itself. Do not multiply the exponent and the base, and that is very wrong. Okay, 1.5 times 1.5 is 2.25. And 2.25 times 2, this is it. Then 1.5 times 5 is 7.5. Okay, that is correct. Plus 3. Then, afterwards, you are going to remove the symbol of grouping, the parenthesis. You are going to multiply 2.25 times 2. What is the result? That is 4.5 minus 7.5 plus 3. Take note, you have to add two numbers having the same sign. Therefore, 4.5 plus 3 is equal to 7.5 minus 7.5 is equal to 0. Okay, did you understand, students? Or you can also have negative 7.5 plus 3 is negative 4.5. 4.5 minus 4.5 is equal to 0. Okay, number 8. This is a rational function. How can we say that? How can you identify that a function is rational? If we have a denominator with variable x. If our denominator does not contain variable x, it is not a rational function. And that will be in the next chapter. We will be dealing with rational functions. At least you have already an idea of what is rational function. It is a function with a denominator containing variable, at least one variable x. Okay, if x is equal to 1.5, what is the value of y? F of 1.5 is equal to 3 times 1.5 quantity squared minus 8. And this is, the denominator would be 5 minus 1.5. 1.5 raised to 2 is 2.25. Times 3, what is the result? Okay, you are going to simplify the expression gradually. No? Or if you have the scientific calculator, you can remove the unnecessary solution. Okay, multiply this 3 times 2.25. What is the result? 6.75. And this is it. 6.75 minus 8. And that is divided by 3.5. Take note, 8 is greater than 6.75. Therefore, you are going to subtract. And the difference will copy the sign of the bigger absolute value. That is why 8 minus 6.75 is equal to negative 1.25. Then divide it by 3.5. The result is 0.36 because it is rounded up to nearest hundreds. Because in calculator, the answer is 0.357. 7 is greater than 4. Therefore, you are going to, from 0.35, it became 0.36. Okay, we will proceed with number 9. This is still quadratic. F of 1.5 is equal to 2 quantity, 1.5 quantity squared minus 5 times 1.5 plus 3. I think we have already solved this, no? Okay, same problem with the other problem just a while ago. Okay, we have number 10. F of x is equal to cube root of 2x minus 11. And what is the value of y? Okay, this is it. Take note, this will give us an irrational number, I think. No? Let's see, by and by. So, our x is 1.5. 1.5 times 2 is 3. Okay, 3 minus 11. What is the result? Okay, this is not giving us a rational number. This will give us rational number because cube root of negative 8 is negative 2. Why? Because, take note, if our index is odd, it means if our index is 3, we do not have the index 1, no? Because index starts from 2. Then if there is no index being seen, it is understood to be index of 2 and that is square root. Now, if our index starts from 3 going to any odd number, the number inside the radical sign could either be positive or negative. But if our index is even number 2, 4, 6, and our radicand is negative, our answer is imaginary. That is not defined under real number. Okay, and that is example letter A. We will proceed with the moderate one because all of those examples are belonging to the easy type. Now, given f of x is equal to 3 x cubed plus 2x squared plus 3x minus 3. And this is cubic function. Okay. What? Find. Number 1, f of negative 2. And number 2 is f of 1/3. Okay. So this is moderate. Because in mathematics, we have the 3 levels of difficulty. We have the easy, we have the moderate or average, and we have the difficult. And the very difficult is the problem solving. And that is the last part of our lesson. Okay, how are we going to evaluate? The first thing that we are going to do is to copy first the function because that will give you a direction, no? In substituting the value of x. Now, from this, you can proceed with the substitution. It means that you cannot see anymore a variable x because x will be given a value of negative 2 already. Because it is wrong that you are substituted x here but you have still the x there. That is wrong because all x's will be having an input of negative 2 already. And this is it. So this is equal to f of negative 2 is equal to 3 quantity negative 2 quantity raised to 3 plus 2 quantity negative 2 quantity raised to 2 plus 3 times negative 2 minus 3. Okay, what are we going to do here? You are going to use your calculator if you have your calculator. But if you do not have your calculator, you are going to use the mental solution. You are going to multiply negative 2 by itself 3 times. Negative 2 times negative 2 is positive 4. Positive 4 times negative 2 is negative 8. Then negative 8 times 3. This is it. Okay. Step by step. Negative 2 times negative 2 is equal to positive 4. Take note, do not multiply 3 and negative 2. That will give you a very wrong answer. Okay. Then you have here 3 times negative 2 is negative 6. And copy negative 6 there. Then after that, take note, you are going to simplify the exponential term. Okay, after removing the exponents by applying the rule, then after that, we have the parenthesis. Remove the parenthesis, then parenthesis means multiplication. Okay, if you're going to have the exponential expression, the operation there is multiplication also. But that exponent signifies how many times the base is used to multiply itself. So that is why 3 times negative 8 is negative 24. And 2 times 4 is 8. Then 6 plus 3 is 9. And copy the common sign which is negative. Because this is credit plus credit. Loan plus loan is equal to loan. Okay, okay. Then afterwards, you are going to combine the two numbers having the same sign. Therefore, 24 plus 9 is 33 and that is negative because you are going to copy the common sign. Therefore, negative 33 plus 8, different signs. You are going to subtract. 33 minus 8 is what? That is 25. And copy the common sign, which is not common sign. Copy the sign of the bigger absolute value. That is why you have 25. Okay. That is problem number 1. Now, problem number 2 is, this is really moderate because your x is 1/3. It means we are going to have a fraction. Okay. This is it. Solution. This is problem number 2. We are going to substitute x with 1/3. Take note of this. We do not have any more a variable x because all x's are substituted with the value which is 1/3. Okay? And don't forget the exponent also, students. The exponent. We do not have the exponent here. The exponent here is 1. If the exponent is 1, it is no longer written. Okay, then you have here the constant. Our exponent here is x is raised to 0 and it is 1. That is why it is constant because no variable being seen. Now, what are we going to do here? We are going to remove all the exponents by following the rule of exponential expression. 1/3 times 1/3 times 1/3, you are going to multiply 1/3 3 times. And that is giving you 1/27. And 1/3 times 1/3 is 1/9. And multiply this already. You can cancel. And the result is 1. Therefore, this is 3 times 1/27. This is it. And this is, okay, this is, take note, 1/3 times 1/3 is 1/9. And this is 1 because this is cancelled out already. And copy negative 3 there. Bring it down. Then after that, you can now multiply. Multiplying two fractions, multiply both the numerator and the denominator. Some of the students multiply this 3 and 1 and also multiplying 3 by the denominator, it is not because the denominator of 3 here is 1. Therefore, 3 times 1 is 3. Then 1 times 27 and that is 3 over 27. Or you can use the concept of algebra. When you say algebra, take note. Algebra is an Arabic term, algebra, which means a science of cancellation and reduction. We are canceling because we want to reduce the answer into lowest term. That is why algebra originated from Hindu-Arab. Okay, so mathematics started from Middle East, and it was the Arabian people who discovered the concept of mathematics, particularly the algebra, the mother of all the branches of mathematics, and of course the mother of all sciences is mathematics, and this is the foundation of everything is mathematics. That's how important is mathematics, and the very important one is the algebra because algebra is applied in our daily life activities. Now we can use the cancellation method. 27 divided by 3 is 9, therefore you have 1 over 9 here. Then, 2 times 1 is 2. Then you have your 2 over 9 minus 2 because 3 minus 1 is 2 and the sign is negative. Now, you have 3 numbers here. Okay, the first 2 numbers are similar fractions. What you need to do is to look for the LCD, the least common denominator, and that is 9. So therefore, this is 9. 9 divided by 9 is 1. 1 times 1 is 1. 9 divided by 9 is 1. 1 times 2 is 2. Then, 9 divided by 1 is 9. Then 9 times 2 is 18. Therefore, this is it. 1 plus 2 is 3. 3 minus 18 is negative 15. Take note, if our answer is a fraction, do not give me a fraction like this one. You are going to apply the rule in which negative divided by positive is negative. Positive divided by negative is negative. And reduce always your answer in lowest term. You are going to reduce negative 15 over 9 because the two numbers have the greatest common factor, which is 3. Therefore, 15 divided by 3 is 5, and 9 divided by 3 is 3, and the answer is negative 5 over 3. You are going to write fractions properly, as well as the negative sign, because I do not accept fractions which are not written in proper way. I do not also accept numbers with negative signs not properly written. Okay, that is the moderate example for evaluating a function. We will proceed with the difficult one. This is difficult. Okay, why difficult? Because it is rational already. Okay, what are we going to do here? Solution. We are going to evaluate f of negative 3 from this given rational number. Okay, this is it. We are going to copy first the rational function. Why rational? Because our numerator is a polynomial of degree 2. This is quadratic polynomial. And our denominator is a polynomial of degree 1. And this is a linear polynomial. Ratio of two polynomials is giving us a rational, not polynomial. Okay. Okay, therefore, if we are going to equate this rational into y, that becomes already a function. So when we say function, there is a graph. So later on, we are going to graph all of these kinds of functions or types of functions. But prior to that, we are going to study first the evaluation of function because this is very important in the succeeding lessons that we have, particularly in the composition of the function, the operation of the function, as well as in setting a table of values to sketch the graph of the function. We are going to substitute x with negative 3. Okay, take note, do not write anymore your x here because it is already having a value of x. So 2 times negative 3 quantity squared minus 5 times negative 3 plus 3 all over 3 times negative 3 minus 5. Okay, what is the first thing that you're going to do? You are going to simplify its term step by step. You are going to simplify exponential expression first. After that, you are going to remove the symbols of grouping simultaneously, but step by step. Okay. So this is it. Negative 3 times negative 3 is 9. 9 times 2 is 18. Did you understand, students? So we did simultaneously performing exponential expression and that of removing the symbol of grouping. Negative times negative is positive already. 5 times 3 is 15 plus 3. And the denominator is 3 times negative 3 is negative 9 minus 5. Okay, you are going to add all of these three integers because they have the same sign. 18 plus 15 plus 3, that is 18 plus 18 because 15 plus 3 is 18. 18 plus 18 is 36. Therefore, our answer is positive 36 over negative 14. Take note, you are going to reduce this into lowest term. Take note, I will not accept answer not reduced into lowest term if it is rational. Take note, rational and irrational. When you say irrational, this is a number that cannot be written into fraction. So when you say fraction, our numerator and denominator are integers. Okay, but this is rational. You reduce this into lowest term. What is the greatest common factor of 36 and 14? What do you think? This is 2. Okay, 36 divided by 2 is 18. Then 14 divided by 2 is 7. So therefore, the answer is positive divided by negative is negative, and this is 18 over 7. Now, how about if our x is a fraction? And this is our solution. Okay, if x is equal to negative 1 half, what is the value? This is it. Negative 1 half, and this is negative 1 half. All x's are given a value of negative 1 half already. Then, you are going to simplify. Negative 1 half times negative 1 half is positive 1/4. Then negative times negative is positive. Then 5 times 1 is 5 over 2 plus 3. Okay, this is it. Okay, step by step. So 1/4 is the result of negative 1 half raised to 2. And here, negative times negative is positive. Then 5 times 1 is 5. Then 1 times 2 is equal to 2. This is it. Then copy positive 3 here. Then after that, proceed with the denominator. Negative times positive is okay. Not yet simplified, no? So what I did is to copy first here. Okay, then we have to proceed with the next step. So take note, 2 times 1/4 is 1 half because you can reduce this, you can use the cancellation method. 4 divided by 2 is 2. Therefore, you have 1 half already, and this is 5 over 2 plus 3. Then, you are going to multiply 1 half, negative 1 half with 3, and the result is negative halves. Negative 3 halves. Then, minus 5. Then, what are you going to do here? Then, you are going to simplify both the numerator and the denominator. Take note, okay, this is the similar fractions. And so, with the denominator, because they have different denominators, these two fractions are similar, but because of these three, okay, it already becomes the similar fractions because they have different denominators. What you're going to do in adding or subtracting the similar fractions is looking for the least common denominator. Okay, so we are going to do simultaneously. Now, this is it. The least common denominator of these three fractions is 2. Therefore, 2 divided by 2 is 1. 1 times 1 is 1. Plus, okay, 2 divided by 2 is 1 times 5 is 5. Plus, okay, 2 divided by 1 is 2 times 3 is equal to 6. Okay, this is. Take note, you are going to arrange the equal signs vertically for each problem. Okay. Then, you are going to look for the LCD of the denominator. What is the LCD? Because you have 1 here. 1 times 2 is equal to 2. That is the LCD. 2 divided by 2 is 1. 1 times negative 3 is negative 3. Then 2 divided by 1 is equal to 2 times 5 is 10, and that is negative. Then after that, okay, we are going to simplify. 1 plus 5 is 6. Plus 6 is 12. Over 2 is 6. Okay, negative 3 minus 10 is negative 13 over 2. This is our answer. So, 12 over 2 is 6, as what I have mentioned just a while ago. Then, you have negative 13 over 2. Then, this is 6. Take note, you have a mixed number. Therefore, to simplify mixed number, you are going to get the reciprocal of the denominator and proceed with the multiplication. Okay. So, 12 over 2 is equal to 6. Get the reciprocal of negative 13 over 2, and that is 2 over negative 13 because it is a mixed number. Then, proceed with the multiplication after getting the reciprocal. Therefore, 6 times 2 is 12. And that is negative 12 over 13. And this is our answer. Did you understand, students? Okay, we have another difficult one. Find number 1, f of 16. Okay, what is the value of y if x is equal to 16? What is the value of y if x is 127 over 54? Okay, so this is a difficult, but this is because if we will not give difficult problems, how are your minds challenged? The more challenge that we encounter, the more our minds or knowledge becomes witty. Okay, that is why I am giving this particular problem. Then if you have any queries regarding our problem, don't forget to get in touch with me in our group chat. Okay, we will proceed with problem number 1 of letter D. Solution. F of x is equal to cube root of 2x minus 5. Then, we are going to substitute x with 16. This is it. Okay? X is already 16. Then, 16 times 2 is 32. Then, 32 minus 5 is 27. Okay, this is it. 27. Take note, actually, this is not difficult. Now, Then, cube root of 27. What number? If we are going to multiply 3 times, the result is 27. If you do not have your calculator, you have the technique. What number, if multiplied 3 times, is 27? And the answer is 3. Okay, that is the meaning of cube root. Okay, cube root is the opposite of cubic. Take note. Reciprocal. Opposite. Inverse. Okay. We will proceed with number 2 of letter D. Okay, copy first the problem or the function. Then we are going to substitute now. Okay. What is the value of y if x is equal to a fraction of 127 over 54? Replace x with 127 over 54. This is it. Okay. After that, you are going to, we do not have the exponent here. The exponent is 1. Okay. Then you can automatically proceed with the multiplication. But take note, 54 and 2 have a greatest common factor, which is 2. No? Therefore, you can cancel. You can use the idea of cancellation method to reduce the answer into lowest term. Okay, therefore, this is it. 54 divided by 2 is equal to 27. Then, these two numbers are dissimilar because they have different denominators. Therefore, 1 times 27 is the LCD. Okay, that is 27. 27 divided by 27 is 1. Times 127 is 127. Minus, take note, 27 divided by 1 is equal to 27. Then 27 times 5 is 135. Actually, I did something to make the answer not difficult as you think just a while ago, no? Okay, because this is giving us a perfect cube. Okay, 127 minus 135 is equal to 8. Okay, that is negative 8 over 27. Take note, 8 is a perfect cube. 27 is also a perfect cube. How are you going to simplify this one? Okay, take note. Okay, negative 8 over 27 is negative 2/3 raised to 3. Because 2 times 2 is 4 times 2 is 8. Then 3 times 3 times 3 is 27. Therefore, we are going to cancel. 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 Then, this is our answer already. Okay, did you understand? Now, we will proceed with your assignment number 4. Okay, this is your assignment number 4. What you need to do is to copy its problem. Then, you have your solution. Problem number 1, solution. Problem number 2, then solution. Take a clear picture of your answer and submit it online in my email address or in my messenger. And this is your assignment. Letter A, evaluate the following functions at x is equal to negative 2.6. Round off your answers in nearest hundreds if the answers are irrational number. Number 1 is cubic function. Number 2 is cube root function. For number 1, f of x is equal to 3x cubed minus 8. Number 2 is cube root function. F of x is equal to cube root of 5 minus 4x. Number 3 is greatest integer function. F of x is equal to negative 3 times greatest integer function of x plus 2. The number 4 is a rational function. F of x is equal to 2x squared minus 5x plus 2 all over x minus 5. Number 5 is also a greatest integer function. F of x is equal to 5x plus 8 all over 2 times the greatest integer function of x minus 3. And number 6 is absolute value function. F of x is equal to negative 3 times the absolute value of 2x minus 5, absolute value plus 4. And letter B, if f of x is equal to 3x cubed minus 8x squared plus 5x plus 2 all over 5x plus 4, and this is rational function, then evaluate. Number 1, f of negative 2. Number 2, f of 3. Number 3, f of 2 third. And number 4, f of negative 2 third. And letter C, given f of x is equal to cube root function. Okay, f of x is equal to cube root of 3x minus 4. Then evaluate number 1, f of 12. Number 2, f of 68 over 3. Number 3, f of 172 over 81. And number 4, I haven't given an example which is like this one, and I hope do something for you to solve this, because actually this is only very simple. F of 2x plus 3. And that ends our lesson in the evaluation of functions. And our next lesson will be operations on functions. And afterwards, we will be discussing the composition of functions before we are going to proceed with rational functions. Once again, stay healthy, stay beautiful, stay handsome. Wassalamualaikum warahmatullahi ta'ala wabarakatuh.